Awesome. Hey guys, welcome. I'm Nick Stinemates.
I'm Corey Sanders. Hello.
We're going to be talking about the Microsoft and Docker announcement. First, we're going to go over a quick introduction of who we are. Then we're going to talk about why we built Docker, what it is, go through a demo. We're going to go over the Docker engine as well as the Docker Hub.
And then I'm going to talk a ton about the Microsoft Docker partnership and go into some more details on Azure and how Docker is coming together there.
So quick overview, I'm Nick Stinemates. I head up BizDev and Tech Alliances for Docker. I'm an open source enthusiast. I've been part of various Linux and open source communities for a long time. But it didn't start that way. I've been programming most of my life. Started actually in VB3 on Windows 3.1. So it's been a pretty long journey. I love to talk. Please get in touch. My contact information is there.
So my name is Corey Sanders, Partner Group Program Manager at Microsoft. I'm actually responsible for the infrastructure as a service product on Azure. But I am a former Windows developer. I actually used to work in the Windows kernel. So I used to write bug fixes for Windows. So all of the things that cause your machines to reboot, those were me. You're welcome. So I like to think I was keeping you secure, but I think you like to think I was rebooting you. 6 in 1. Okay, so the other thing is I am relearning open source. It's been as sort of when I joined Azure and started working on infrastructure as a service, I did a ton of Linux work back in when I was in college and did a bunch of development on that, on those environments. And when I came to Microsoft, obviously, when I joined, there wasn't as much opportunity for Linux development when I first joined. I'm excited that there is now again, and so we're sort of relearning open source in that experience. So I actually started on Visual Basic 2, but I actually started on the Apple IIe, and so I remember driving my first little man that jumps up onto a diving board and jumps into the water and animated the whole thing. It was terrible, but it was fun. And I do like making jokes, and I will be making jokes, and I will expect you to laugh at my jokes, whether they are funny or not. So specifically, Nick has to laugh at my jokes.
I'm trying. Really hard. Quick question. How many of you in the audience are developers? Raise your hands. Perfect. And how many of you are traditional sysadmins? Okay. And how many of you are DevOps, or DevOps in your title, something like that? Okay, perfect. So applications have fundamentally changed. 15 years ago, they were long-lived, deployed to a monolithic server. And today, increasingly, deployment is iterative and constant. Some environments deploying hundreds or 1,000 times a day, built from loosely coupled components and deployed to a multiple amount of servers, whether they're on-premise or in the cloud. So we think the image looks a lot like this. You have fundamentally a lot of different things like static websites, back-end workers, web front ends, etc., that need to be deployed across a multitude of different environments, from a developer laptop to a QA server, through continuous integration of some sort, into pre-prods, maybe on-premise or in the cloud, and then ultimately to a cloud destination. So we affectionately call this the matrix from hell. You have a whole bunch of different components that need to be deployed across a whole bunch of different servers and different server architecture. So we actually took inspiration from the cargo industry pre-1960s. Everything was then shipped in its own specialized container. So coffee beans in sacks, oil in drums, pianos by themselves, cars by themselves. And as soon as they went from port to port, they had to be unloaded and reloaded, and logistics were a complete nightmare. And the solution seems rather silly in retrospect, but it's a steel box. What made it special is it's a standard steel box, same size, same dimensions, same weight. And that separation of concerns was created from core shipping infrastructure providers, like people who owned ships, trains, trucks, cranes, didn't actually have to now worry about what was inside of the box. And separately, manufacturers actually didn't have to worry about the things outside of the box. They just had to worry about things getting from point A to point B. So we turned the industry from what's there on the left. It's a picture taken from on the waterfront to the picture that we have there on the right. 90% of all cargo is now shipped in a standard shipping container. There's an order of magnitude of reduction in loss as a result. Huge reduction in freight cost, and 5,000 ships deliver over 200 million containers. I don't know how many of you have ever been to a ship port. It's pretty amazing to watch the level of automation that's there. So effectively what Docker aims to create is a shipping industry, if you will, for code. We think it's pretty unnatural that it's easier to ship car parts halfway around the world than it is to move an application from one data center to another. And so Docker effectively eliminates the matrix from hell. And we're gonna get into a demo in a bit that will talk more about how that happens. But first, let's talk about the importance of that ecosystem. Back to the shipping analogy, if you didn't have an infrastructure built around these steel boxes, these containers, you effectively don't get the benefits of standardizing on a steel box. You don't imagine if you had to create ships which dealt with different steel box and had to change the railways every time you wanted to move from a ship to a train. That just doesn't make any sense. So some of you maybe, if you have a Linux background, may be saying, wow, well, containers have been around in the Linux ecosystem for a very long time. Yes, that's true, but as we talked about earlier, just having the raw container and having shipping containers aren't just steel boxes. That's what I'm trying to say. With Docker, you get a few low-level primitives. You get sort of ease of use and tooling around that. The developer experience is really nice. You get reusable components through Docker Hub, which we'll talk about. You get deployment onto any infrastructure. And you get to move between any infrastructure in a matter of seconds. And effectively now Docker's reached such a critical mass that containerization is effectively Dockerization. So let's talk really quick about the ecosystem that we've managed to build in the last 15 months, 16 months now. The thing about this slide is that it's always out of date. We have about 640 contributors to the open source Docker project, 250 meetups meeting in 29 countries. By the way, we have a global meetup tomorrow that's being held here. 29 countries there, over 1,100 people. The people who win that Global Hack Day Challenge get a full expenses paid trip to DockerCon Europe, where Microsoft will also have a presence. So please come out to that. There's more information, I believe, in the backpacks that you all got. We have a bunch of sort of web scale, I guess that's the right word, users, early adopters that have been using Docker for the last year or so with published use cases. Typically, these are for organizations now that have the engineering know-how and resources to put together a distributed application across thousands of machines. We're effectively working to make that easier for everyone. We have a wide set of curated content that comes from the ISVs themselves. So if you want to start and deploy a Redis cluster or a Mongo cluster across 1 to 10 to hundreds of machines, that's really simple to do. Docker as a business offers enterprise support, as well as community support and all of the rest. The documentation is available. There's a tutorial on the hub, which we'll talk about. That doesn't require you to download anything, but it gives you the full experience that I'm about to show you in a sort of hands-to-keyboard type way. And we have a number of partners. That's one of the reasons why we're here. We've been working with Microsoft. 2 weeks ago, there was a great announcement about the two communities combining. We're going to talk more about that in a few moments. So as we talked about a bit, let me pause actually and say, at any moment, please feel free to raise your hand. I'm always scanning the audience. If I say anything that doesn't make sense or I need to clarify, please interrupt me. This session will actually be pretty short if you guys don't have any questions. So, so the Docker engine is an open source project written in Go. one of the beautiful properties of Go, and it's also one of the downsides, is that you can get a single binary that can pretty much be deployed anywhere. It brings its environments with it. And so you have this lightweight 7 meg thing that can run on any Linux environment today. We released it in March of 2013. It provides the Docker container, which is effectively at the Linux kernel level, cgroups and namespaces that provide sandboxing to isolate processes from one to another, as well as specialized network and storage for each container. Go ahead.
What's the difference between this Docker container and one that I write with an application in it?
So the question is, what's the difference between a Docker container and a generic container, like, let's say, provided by LXC? The difference is nuance, because the Docker experience you can actually get with an LXC driver or a libvirt driver, or by default you get it with the libcontainer driver produced by Docker. But basically you get the ecosystem along with it. I don't know about you, but building a LXC container from scratch without using the Docker tooling is actually really difficult to do. And creating the LXC template correctly and getting all of the defaults right with all of the right security permissions is really difficult. And so Docker sort of abstracts all of that away from you and provides the ability for you to share that easily. So there's Linux and soon Windows CLI tools. Corey, actually as a part of the demo, is going to show Docker CLI running on Windows, connected to a Linux backend for now. There's also a local and remote REST API. It's available locally through a Unix socket, and it's available remotely, secured by TLS, in case you want to interact with a remote server on some cloud provider. And there's also a low-level API for runtime, storage, network, etc. The defaults, batteries included, storage options are there with device mapper, AUFS. Again, we'll get into this. But there's an ever-increasing need for, well, what if we want to use ZFS? That's possible. So let's get into a quick demo. I'm going to switch over. I think it was 7. Perfect. You guys see that okay? Perfect. So I talked about the Docker binary being super simple and lightweight. I've installed it. By the way, it's available on pretty much any package manager that you can expect or think of from a Linux packaging perspective. It's available from the Docker website to install, and also great partnerships with a lot of cloud service providers like Azure for easy installation. So you can basically just bring up a Docker host and get going. So the default experience is to type out Docker, and you see there's a whole bunch of different commands. It's actually gotten more complicated in the last 15 months. But the basic thing you want to do, let me clear this out. So I'm going to run from an Ubuntu image, just echo hello world. And you notice very quickly what we've done. We've actually created a new container. We've isolated that process into its own cgroup and namespace. We've mounted an AUFS file system in the background for read-writes, for union file system of layers, which we'll talk about. And that was all done relatively quickly. And so let's actually talk about sort of the power of that right now. Who in the audience before has started their own VM? Okay. So I'm going to effectively do the same thing with Docker right now. How many of you started a VM that fast? Okay. And to prove to you, there's only one process actually running in this container. Here, let's try that again. How many of you have started 2 VMs that quickly before? Actually, in the time between, I was actually talking between about the previous one and this one. Your first VM probably wouldn't be done booting yet. So let's do something like really destructive. Let's remove like etc passwords from here. Let's go back into a container. If I cat etc password, how many of you think that this is going to fail? Leading question, I know. And how many of you think that this will succeed? You're right. Well, why is that? So as I talked about before, every time you do a Docker run, you take that base, which is the Ubuntu userland that we have there, and we mount a read-write layer on top of that. And so effectively, you have Git-like access for your application. And so whenever you want to make a change, you actually commit it. And we can store those changes. And so let's go into that. Let's go back into this container. Let's remove etc. Here, let me clear this again. Let's remove etc password. Okay. Now let's open another terminal here, and let's do Docker history. Actually, no. Let's diff. Let's do a Docker diff of 2b5ff. And you can see, very interestingly, that as a part of changing, we now have stored the fact that we deleted etc password. And if I come over here and I touch hello world, effectively creating a file, now you can see I've added hello world. And so that gives us a lot of very powerful properties. One is that if I have two nodes, all of which share the same parent, or I have two nodes which share the same application, then the cost of synchronization is effectively none between two machines. They share the same set of information. However, if I make an update to my application and I want to deploy that, and it's in a layer, all I have to do is deploy that layer to that machine. So you get true binary updates.
What's a layer?
What's a layer? Great question. So you see this difference right here that I've shown. We snapshot that using the file system into a single layer. And so at the moment that you commit this change and create a new image as a result, we store that in two layers. Now we have the base Ubuntu layer, and we have the second layer that sits on top of that, which is just the changes that you made to that layer. So let's see how you do that. Like a git ref. There you go. Exactly. And so you can imagine a tree being built, right? You have your root nodes, which can be imported. It's any sysfs today. There's a BusyBox image that's 5 megs. There's the CentOS, the Fedora, the Red Hat from RHEL, the the Ubuntu from Canonical, etc., available for you to start building your applications on. And you can see at any point, any image, the history that it went through to get to the point at which you're at. So full introspection APIs are available. So let's commit this and prove that out. So I'm going to Docker commit this 2b5ff, and what that's going to do is give me this very long image ID, and I'm going to tag this as broken Ubuntu. Okay, and so now if I Docker run broken Ubuntu, and I cat etc passwords, this should fail, right? Because we removed that image effectively from the tag that we now have as broken Ubuntu, which is a composition of those two layers, the base Ubuntu, as well as the next node, which is the removal and the addition of the hello world file. And now we can do interesting things, right? We can take a look at the history of the broken Ubuntu. I'm sorry, what was the question?
Where did you get 2b5ff from?
Great question. So each container gets its own ID. And if I docker ps, you see it right now. I have my session open here. Oops. So I'm going to touch hello world 2. And I actually got it from here. It was a hack. We basically set the host name of the machine to the first few bits of the full UID. But at any point, you can docker ps, and you can see every container that's running on the machine. So if I wanted to, as an example, bring up another container, and then I ran docker ps again, now you can see I have 2 running. And I can do interesting things like detach from this one, and you'll notice it's still running. And then I can reattach. And now I have basically like screen-like capabilities. Now I have my session back. So we looked at image composition, and we talked about sort of the way that layers are put together. Let's talk about image automation. So no one actually wants to go in and type in these Docker run commands to actually install their app. We have a file called a Docker file that can sit next to your application. And while I was setting up, I actually created a little directory here with a file called a Docker file. And it's really basic. It starts with from Ubuntu. It sets the maintainer with my name. That's optional. I just really like talking about myself, so I wanted to add that there. First thing we're going to do is run an update, and then we're going to install Python Flask, because I created a simple Flask application. I'm telling the Docker engine that this app is going to expect network traffic on port 5000. That I want to add the contents of the current directory inside of the container to /app. And then when I start the container, the command that I want to run is python app.py. And you'll notice there's nothing fundamentally I had to change about my application in order to run inside of a Docker container. Actually, it's any simple Python app, and if I were to run this on the host with Flask installed, it would run exactly the same, unmodified. And it's obviously really complex. I'm showing my engineering prowess here by writing my 10 lines. So effectively what it does, if you go to the root, then it returns hello TechEd. So let's build that. So I'm going to build docker build -t app. And that was pretty quick. Let's now run that. So I'm going to say, hey, Docker engine, this exposed. This is exposing traffic on port 5000. Let's automatically route some traffic there. Let's run that in the background. And now I have that quickly this app spun up. And so again, if I docker ps, you can see here the entry with a wonderful auto-generated name that is condescending Tesla. 2 things to point out here. One is that my app has been running, which is great. The second is the ports at which it's exposed on. So if I go to localhost 49169, then what's going to happen is it will NAT into port 5000 inside of the container. And so effectively, 49169, I get hello TechEd, right? And if you want, I can load it in a browser as well, but it's, So let's make a change. Actually, first, let's look at Docker history for our app. And you can see fully how the Docker file actually gets represented into each of the layers. Each of those commands that we entered inside of the Docker file translates into a layer which gets shipped around. And so, as an example, when I make a modification, let's do so. Let's make a, oops. Let's change this to double quotes, and then let's make a modification. And then if I rebuild and then rerun and Docker PS, there's two things that I want you to notice here. One is that the name of the previous one, and I'm sorry it's hard to see because of the font size I had to adjust, but the name of the previous one is actually no longer app. It's now the first part of the image ID. And the reason that is, as we talked about, right, layers are a series is a tree starting from a root and series of changes being applied. Well, at some point, because we made this modification to app.py, we have a split in the tree. And now the pointer to the name of app has been pointed to this one, as opposed to the one that was there on the sort of the leaf node. Just to show you that it's as a result of a modification, I'm going to start, I don't know, 10 or so versions of this application, and now you'll see that the name of this app sort of stays consistent because it's the same version, it's just another copy of that running. By the way, that was pretty fast. Wasn't that pretty cool? Okay. Also, have you ever tried to run two versions of the same application on a single host and it being painful, especially a Flask application? If I wanted to do that, typically what I would have to do in the second derivative, is come in, change app.py, come down here to the port number, and say, oh, now by the way, listen on port 5001. And if I want to set up another one, then port 5002, et cetera, et cetera. So this was like my first aha moment when I first started using Docker was, wow, I can actually now start spinning up multiple copies of the same container. So if I start to make a change and I want to show a colleague, this is something that actually happened to me. I was working on my blog, and I had 5 different style ideas. And we had the designer and the Docker team, and I sent them 5 URLs, which was basically 5 containers running on my local machine, all at different ports, and said, hey, can you help me with this? And that was actually pretty cool. Like, took 0 effort on my part just to start sharing that. So, go ahead. I missed the last part.
What about bad neighbor syndrome? So can you quoterize?
Great question. So the question is, if you have multiple containers running, how do you ensure quality of service for the container effectively? Can you set quotas? You can, absolutely. So what you can do effectively is at Docker run time, I believe you Docker help run. You see there's a whole bunch of commands that you can, or are options you can pass into the command. One of those is setting CPU sets. So here you can say only execute on CPU 1 or set CPU affinity for your application. So basically a modified nice if you're familiar with that. All managed by underlying cgroups technology. You can also set CPU shares. You can also set, -m for memory. So you can constrain how much memory your container is allowed to use as well. Okay, so that's it for the demo. I'm going to jump back into some slides unless there are any other questions. I'm going to mail you a t-shirt, by the way. I didn't bring any here. I think we have some at the Hack Day tomorrow, but I'll mail you one. Thanks for all the questions. That's supposed to be a prod for the rest of you as well, by the way. So I did a bit of an injustice, if you will. I compared containers to VMs. They're not the same. But I did want to show the properties of the sandboxing and the network and the storage that are there. But here's the key difference. In the VM world, you take a server and a host OS and a hypervisor measured in gigabytes, pair that with guest OS also measured in hundreds of megabytes. Finally, you get to your binaries and your libraries, and then you have your application. In the Docker view of the world, yes, we still have a server, and yes, we still have a host OS. But you remember that tree that I was talking about, where you build from a root node and then you have leaves, etc. For anything that is shared, so as an example, maybe I've standardized on Ubuntu with Python 2.7 that's installed in this way, and my deviations are the different Python apps that get run. Well, that same Python 2.7 shares the same memory mapping, shared dynamic libraries, etc. And so when you create new instances of that application, you actually get a whole bunch greater density. But also allows for you to have Python 2.7, Python 3.1, Python 3.2, etc. running side by side in various containers without any issue. Go ahead.
What's the patch cycle on that then? If you've got 100 containers running,
Yeah.
do you patch within the container? Do you have to rebuild your container every time you go through a patch cycle of some shared libraries? Or?
Great question. So the question was, what happens during a patch cycle? Say there's an update to my application, what do I do? Do I have to update inside of the container? Do I update outside of the container? Etc. So thanks for that. I showed the Docker file earlier, so that's equivalent to a make file, if you will. And so Docker sort of takes care of that for you in terms of building the new container. Effectively, you pair your Docker file with your source code. And there's tooling, which we'll talk about, that can automatically convert that into an image for you. And then tooling also, which can deploy that to all of your Docker managed hosts. So effectively, the patch cycle allows you to do interesting things like run the same application twice, also allows you to run two versions of the same application without conflicting. And so you can do red flag deployment very simply. You know, a deployment where, say you have 100 nodes, 50 of which you want to update to the new version and slowly sort of grow that as that's being accepted in production. So this concept of zero downtime deployment or of features being updated per zone is actually pretty simple in the Docker patch model.
So as you're rebuilding those, then are you rebuilding a tree?
Yes. So what's cool is what Docker takes care of is if nothing in the parent has changed, then it just caches that and starts building on the next. So you don't have to resynchronize every time you make a change to any parent changes that were unaffected. So the updates to all of your nodes is actually just that layer that's missing, or the set of layers that's missing depending on how you've constructed your images. Okay. So let's talk about Docker Hub. I've alluded to this a few times. It launched in June of this year. Previously, if you're familiar with the Docker ecosystem, it was called the Docker Index. But its function is to enable any Docker host to run any application in seconds. So it stores all of those images and all of those layers and all of the metadata associated with that. It also provides official public and private Docker images. So if you want to share, or you're a company that wants to share their applications with the world, that's fine. Docker Hub is a great distribution channel, and in fact, there's a lot of companies, which we'll talk about, that do that. If you want to keep things private and run sort of in the future in a behind the firewall configuration, or right now in public, hosted in public, but only viewable to your organization, very similar to how GitHub organizations would work with code sharing as an example. That's also possible. And there's workflow management. So you can integrate webhooks into, as an example, change happens in GitHub. That triggers a hook inside of Docker Hub to rebuild your Docker image. Maybe that kicks off another webhook to a deployment script that takes your image and deploys it to any infrastructure provider of your choice, whether that's on-premise or off. So here's our view of the world. Obviously, we're at the center of it because we're like that. On the left-hand side, you have source control, QA systems, dev laptops, staging environments, etc. And in the middle, you have Docker Hub. And Docker Hub has a set of users. It also introduces this thing called provenance, which we'll get into. Those public, curated, and private registry types, and third-party tooling for integrations, sort of above the line in terms of workflow automation, and then on the back end for physical virtual or cloud infrastructure. Corey made the wonderful modification to turn the Azure cloud there blue. So let's talk about provenance. Wouldn't it be great if each of the images you received, whether it be from Docker Hub or from a colleague, you could verify the contents of a layer, as we talked about, were digitally signed. And you could make sure that they weren't tampered with in transit. And imagine coupling that with being able to sign your own images out into your own infrastructure. And maybe you're like on the secure boot bandwagon, so now you have your hardware secured all the way up to the OS level. And now you can tie that into your application level. And what you get is a fully trusted, bottom to top, or top to bottom, depending on how you want to look at that, cryptographically signed applications. So today, what's available is all of those curated images that we talked about. There's about 40 of them are available and signed. We'll be bringing out features in the next few months so that you can sign them yourself and start using that model across your organization. I want to reiterate here that Docker today runs on any infrastructure that can run Linux, and it's a modern version of Linux, unless you count Red Hat, which is still running 2.6.3.2 version of the kernel. But basically, any new version of any distro supports Docker natively. And soon, Windows will as well. So we talk about Docker as a combination of the two things. There's the engine that's public and open source, and then there's the hub for the content and distribution model with APIs on top and below. On top to integrate with the ever-increasing, I believe the number today is around 49,000 applications contributed by the user community of various quality, no doubt. And about 20,000 projects with Docker in the title on GitHub, with something like 50-some-odd thousand Docker files actually in GitHub repositories. So pretty great adoption numbers. With curated content provided by Nginx, Redis, we talked about the Ubuntu provided by Canonical, all of the distributions for userlands, etc. If you want to get a WordPress site up and running from 0 to 5 seconds, it's possible. Corey's going to show in a bit starting and running a Minecraft server as well as a Minecraft client using the Windows client. It's pretty cool. And again, this runs on any infrastructure on the southbound. With that, I'll turn it over to Corey.
Nick. Great, thanks. Thanks, Nick. All right, that was great. A lot of Linux stuff up there. Really, I learned a lot actually just watching. So I wanted to spend a little bit of time talking about Microsoft and Docker, and then I'll spend a deeper conversation on the Azure side. So the recent news that we went out with actually about a couple weeks ago. This was the picture that was in the blog post. It should be very, very clear exactly how we're doing it since it goes into a lot of detail. No. The whole idea, everything that you just saw from Nick, all of the ability to take those same containers and be able to move them between different hosts, to be able to go from a development environment, that was all on his box, to be able to take that and move it into a test environment or move it into a production environment and have that level of guarantee that it will be the same, and that level of isolation between. That's all great technology that we want to make sure that we enable as part of the Windows ecosystem as well. And so the conversation that we ended up having with the Docker guys over, and including Nick, over the last, I guess, month is probably when we first started talking. We sort of came to the conclusion, look, we want to do containers in Windows, right? We want to do containers just like, well, not just like, but we want to do containers like Linux. But we want to make sure that we have taken advantage of this really blossoming community that really shows, based on the pictures that he showed you, the ability to take these things and move them around. And so as part of that, the idea that we've sort of come up with and what we're planning to execute on is we are, as part of Windows, we will add container support inside the OS. It will be sort of embedded in the OS to be able to put these containers in. But we will, from Microsoft, contribute to the Docker Engine project, which is an open source project. And so we will contribute to that project to make that Docker Engine work on top of these Windows containers. So it is two pieces. It's important to sort of keep in mind that it is two pieces, one that is sort of embedded in the OS and one that is going to be sort of that same engine concept that exists on Linux. It's important to sort of let that sink in a little bit, right? So this was a fun thing to actually do inside the company. Microsoft will be building a piece that will ship and work on top of Windows as a part of an existing open source community. So it's a very exciting time for us to be able to join this community and bring Windows to it. There's a few things that are important to point out with that. One, this doesn't actually mean that Linux binaries are going to run on top of Windows. It's a very actually common misconception. So if you had it, don't feel like, oh gosh, why did I think that? No, so the whole point, as Nick brought up, is that these containers share from the underlying OS, right? They pull content from it, which is what makes things spin up fast. They share across the containers, right? So when you're spinning them up, if there's libraries that are being shared across them, it will share across them. Which means if you put a Linux container on top of Windows, there's nothing to share. It doesn't really make any sense. So the Windows containers will run on top of a Windows host. Linux containers will run on top of a Linux host. So we're not making it sort of the same host underneath. Yeah, go ahead. Say that again, sorry. Oh, what's the difference between app-v? Yeah, it's a great question. So, one of the things that I will say, we are also doing something new at Microsoft where we are announcing things way ahead of actually having them completely finished. And so, I'm sorry, not way ahead. He's working on it right now, actually. There's Taylor over there. We pulled bits and pieces from a lot of the virtualization technology that we have. So there are bits and pieces of the app-v technology that we'll be leveraging. There's also bits and pieces of some of the other technology that we've used for containers in Microsoft for a long time. And so we're sort of pulling these pieces together to make it work. The key thing about well, I'm not going to get into too many details actually about, we should take that afterwards with Taylor about exactly the details of what we're building, but they're working on it right now. But there are pieces of app-v that are coming into it for sure. So that's kind of the key point there. It is pretty exciting. The last point is worth just pointing out. We are ahead of this announcement actually. We will be announcing, because right now, when you're using Hyper-V and you're spinning up virtual machines, you actually can spin up both Windows and Linux virtual machines. And so we are planning to add support. This was also a part of the announcement for just local box deployment using Hyper-V and being able to go straight into a Docker container that's running on top of Linux. That will require the usage of Hyper-V, so it does require sort of the server VM to do that, server host to do that. But that we will be announcing and releasing sooner than the actual container support on top of Windows. So the exciting part about this is we do feel like this is actually bringing these two communities together. I spent a lot of time on this one. Are you ready for this? Hold your breath. What? And there we go. Okay. That's the aha moment, I think. Is it? What's that? I don't know. I made it, so I think, anyway, let's watch again. Oh, that's a shame. I didn't mean to do that. You know, give me a minute. Let me change it. No, just kidding. The whole point is that it's coming together. So anyway, okay, I'm going to move on. So the exciting aspect of this, as we continue to work on sort of this overall ecosystem, is we do believe that that bringing together will offer new opportunities for deployment of applications. You know, how many of you actually work with Linux at some point? And how many of you work with Windows at some point? Right. And so there's a ton of application, there's a ton of deployments out there that span them both, or that you have to deal with both, you have to work with both, and obviously all the hands went up for both questions. And so the idea here is that the power that Docker can bring is it can actually bring a consistent experience on top of both of these ecosystems, right? And so it allows you to build these containers that may be able to span across one instance for Windows, one instance for Linux, or maybe 2 for Windows, 3 for Linux, whatever you want. And it allows you to take that and be able to deploy them in all environments, right? And so, yeah, go ahead.
Are you expecting there to be any Windows Server licensing changes for this?
It's a great question. So the question was, do I think that, I shouldn't even repeat the question. Yeah. No, do you think there will be Windows Server licensing changes? We have not yet figured out the exact details of the licensing. Obviously, the premise and the goals of what we're shipping is to make it easy to be able to move from these different environments. So that is the underlying goal and strategy of what we were trying to enable. The exact details of what the licensing will look like are still not written down. Plenty of conversation, but still not written down. So we'll have to get back to you on that. And so, yeah, again, the idea here is that you can deploy these, and I'm going to show you a bit on sort of Azure. Yeah, one sec here. I'm going to show you a bit on Azure. But the other thing to keep in mind is that these containers for Windows are not going to be limited to just an Azure environment, right? And so that is kind of an important point. The whole idea here is that they can move between environments. And so if you end up using some of the other competitive cloud providers, you can actually deploy on them as well with these new Windows containers. So something to keep in mind. Yeah, go ahead.
So already thought about delivering containers as well for the Microsoft products as applications?
Say that again, the Microsoft products and what they're going to look like.
Yeah, for example, Microsoft Dynamics.
Like whether SQL will work or Dynamics will work? Yeah. So it's a great question. So we've actually kicked off investigations with all of the internal Microsoft teams. You know, some of those products are going to be more tenable for a containerization type solution. Some of them that have heavy dependency on the local disk or sort of a lot of persistent storage may not work as well in the environment, but we are actually kicking off conversations with all of them. The fast startup time and the mobility between environments we think are going to be great for all those products. But it does come back even to the previous question. All of them need to be thought through with licensing in mind and how licensing will work. As many of you know, some of those products are core-based licensing, which makes them very complex when you start looking at how that works from a container perspective. So we definitely see these issues, and those conversations are started. You know, like I said, it is a change for Microsoft in that we are announcing our intentions without having thought it all through. And so we are definitely aware that these things need to be thought through and are working on them. But I don't have a good answer for you right now. I shouldn't have taken any questions. You got me into this. Yeah, go ahead. Yeah, great question. So as of right now, the answer is it's mostly geared towards server. We have also had conversations with the client guys about this, but it's mostly geared towards the server. It ends up being more of a server application, server deployment model that we've sort of been playing with, specifically looking at. Say that again? I couldn't hear you. Yeah, that's right. That's right. Yeah. So I think, you know, it definitely, as we continue to expand out the ideas here, we will definitely take a look at that. But it really is pretty focused on the server side for now. Yeah. Any other questions? Okay. So let me actually dig into a little bit about what we're doing with Azure specifically. So on the Azure side specifically, what we actually already have today, and Nick kind of alluded to this when he was up here, using our extension model that we offer in Azure, which is technology that allows us with a very thin agent, when you spin up a virtual machine in Azure, whether Windows or Linux, it can pull down specific agents that are third party or first party and offer it and drop them onto the box. For Linux, what we offer today is there is a Docker extension. It's actually been there since DockerCon, and so we announced that extension at the same time that they announced the Engine 1.0 release. And so it ends up being, basically pulls this guy down when you say, hey, I want to deploy Docker. It'll pull it down and drop it right under the box. And so the Docker hosts, the command line experience that Nick showed you and I'll show you on the Windows side, it actually automatically does all this. So it goes in and calls the creation of the virtual machine such that it pulls this down. The goal being to make it even easier. Everything that Nick showed you was incredibly easy. We want to make it even easier to run on top of Azure Linux VMs. And so it will be updated with the latest. We'll have that always updated as part of that extension gallery and be able to deploy it. Okay. With that, let me actually show you a quick demo. So this is what I'm going to show you here is the Docker client running on top of Windows. So this is very, very new. We actually finished this on Friday, and then it was in the keynote if you saw it. We were all nervous. But yeah, so what it ends up doing, it's effectively a move of that Go client that Nick was showing to run on top of Windows. And it integrates here, it's integrating directly with some hosts that are running on top of Azure. So the one thing that it can't do, of course, is it can't run directly, like Nick showed you, on this box without spinning up virtualization technology, VirtualBox, or Hyper-V coming in the future. But, of course, I can do it on top of Azure. And so this port allows you to do all these commands from this Windows client. And so like here, I've got Docker hosts. I actually want to set, I've got the wrong host selected. So let me select the right host. I'm going to move over to Ubuntu. And so here what I've got is, as Nick showed you, I've got 3 hosts set up. So these are 3 virtual machines running in Azure. And I'm going to use the Ubuntu one. And so just to show you sort of very similar experience, let me just go ahead and take a look. There's nothing running there. Let me show you a very similar experience to what Nick showed. And so here, I actually can directly from my Windows client pull up a bash prompt right onto that Ubuntu running Linux VM and be able to run commands straight from here.
Is it a native port or is it in C# or what?
No, it's actually a native port. So it's actually, we moved Go over and made it work. Yeah, good question. And so here I've got, Linux running here, Ubuntu running. I can go in. Oops, not what I wanted to do. Okay, not what I want to do either. Anyway, you can see I could do whatever I wanted to do. Yeah. Can you tell that I'm not a great Linux guy? You're laughing here, right? Yeah. What do you want me to do? Should I do something? All right. Let the Windows guy do the Linux demo here, huh? That's the whole joke. Okay, so. And you see, I don't even trust myself to type. Like, I've typed the commands a bunch of times, but anyway, I'm going to use pre-created commands here for me. So the last part of this demo that I'll show you here, let me go back up. There it is. So we do also happen to have a Minecraft image. We pulled this straight from the hub, from the Docker hub that Nick mentioned. And so I'll go ahead and run this. And so this is, again, running on that Ubuntu server, running in Azure. And so we'll go ahead and connect here from the client. And so that spun up amazingly fast to spin up that server and that remote game. So this is a little bit slower here. Okay. All right, and so I'm sure, how many of you played Minecraft? Yeah, this is my first time. I should probably have played it more now that I'm at Microsoft. Okay. Or now that Minecraft, anyway. All right. And so that just connected to the server that I set up. And so within seconds, I had this Minecraft server, or sub-seconds, I had this Minecraft server set up as part of this host that was running Ubuntu in Azure. And then I'm able to immediately connect from it here with my client. And let's see here. Oh, there we go. Seems to be doing something. It's not really responding. Oh, there we go. Okay, here we go. And so here I can now run around and do what you do in Minecraft. It's not really responding very well. But anyway, it must be the network. Let's blame that. Yeah, there we go. Okay, good. Anyway, so that's Minecraft up and running. Exciting. Okay. Any questions about Minecraft? Anything? Nothing? Okay. All right. We'll move on. So one of the really exciting things that we're working on is the integration of the Docker Hub as part of the Azure Marketplace. So we announced this marketplace actually today. So the launch of this marketplace and the growth of the content that we've got there is very exciting stuff. But what we're really excited to go do is make it really easy and really clear how to go deploy content from Docker Hub straight into an Azure VM through that marketplace. And so what we'd really like to see happen is, yeah, go ahead.
Sorry.
No, that's all right.
Just earlier, when
You did have a question about Minecraft.
No.
Oh, okay.
diffing containers,
Yeah.
how is that going to work on if you're building a Windows container? For example, diffing the registry as well as diffing the file system.
So you're asking how will diffing containers work for Windows? Taylor, do you have a good answer for that? It should just work, right? I mean, it's just going to look at those files. I mean, it should just work just the same way. Okay, so the idea here is to be able to take this hub and be able to make it super easy to deploy this content straight through the Azure Marketplace. And so that includes a few things. It includes things like making sure the content's nearby, replicating it around the world to make sure that the data is nearby and up to date, and always sort of in tight collaboration with the sort of the original Docker Hub, and then using sort of the certification that Nick talked about to make sure it's sort of the trusted content that you expect it to be. And so we're working through this right now, but we do expect it to be really easy and really fast to be able to just deploy these containers onto VMs that are running, hosts that are running right onto Azure, and be able to use that amazingly fast. And so sort of the last point that I'll mention that I talked a bit about, the idea that we are working through with the Docker guys is being able to take sort of orchestration across multiple containers. And so the idea is using the open orchestration APIs, which you'll hear more about tomorrow. Am I pre-announcing? You'll hear more about them tomorrow if you do come to the Hack Day, is the ability to take sort of multiple containers, multiple Docker containers, and orchestrate them and deploy them. And if you think of this in the future where we've got both Linux and Windows, you start saying, right, I have two servers, two hosts running in Azure. I've got a Windows host, a Linux host, and I've got all these containers. And this will just orchestrate and deploy them, connect them, and make that app run together. And so for that app, you've got maybe your workers that are Linux, your front end, your Nginx that's Linux as well, but then maybe you're using SQL Server in the back end. And so it allows you to put these pieces together and deploy truly hybrid or cross-platform applications in a very, very easy, predictable, and repeatable way. And that is kind of the goal that we've got as we build this through. I animated again. Look at that. Okay. And so to give a quick recap, we're pretty excited about the momentum Docker has. Nick showed you the ability and the power that it offers, the ability to run across multiple platforms, multiple experiences, from desktop to Q&A to production, and have an identical and very, very fast and agile deployment experience. This partnership we feel really excited about because it's bringing all that power to Windows and bringing Windows to that Docker ecosystem. And so it's sort of a great experience for both. And the idea, of course, is that any workload can be deployed anywhere on any system. And so that is the goal, with, of course, Azure being the best place to deploy them all, but they can deploy anywhere. So I am the Azure guy, I have to say that. And so that's kind of the overview. I wanted to make sure that we had plenty of time for some questions since this is fairly new content for a Microsoft conference. And so while we took a bunch of questions during the session, it'd be good to kind of get some follow-up as well. And we'll also be hanging out as well. The one thing I was going to say, I don't know if Nick, you want to come back up as well. The one thing I thought would be interesting, and I hate to put you on the spot since I didn't ask you about this, if you had a bunch of those customer stories up there, I don't know if you wanted to walk through one of the more interesting customer deployments of Docker today and just kind of explain it. I think that may be a nice way to open up some more questions, and then we can leave it from there.
Sure.
Did I put you on the spot?
No, it's fine.
Okay.
I'm always ready.
Yeah.
I actually like being put on the spot. So, you know, okay, question back there, then I'll get to it. That's how you know someone's really paying attention.
That's right.
So thank you for that question. So the question was, what about multi-tenancy? Is it a goal of the project to make sure that you can run 2 apps side by side, maybe from 2 different providers? Maybe.
That's how I answered all my questions.
The reality is that Docker is at a different level of abstraction than VMs. And so with Docker, you have what they call OS-based virtualization, which means that there's a shared kernel for each container. So there's naturally going to be some attack vectors that surface as a part of a containerized deployment that don't exist inside of a VM-based deployment. However, there's increasing complexity and increasing security focus being added with complementing containers with things like AppArmor, GRSec, or what is the one that Red Hat is famous for? I'm thinking about it in my head. I don't know. It doesn't matter. So that's one way. I don't necessarily tend to think that root inside of a container is actually a symptom of good things happening. But maybe that's required. But today, the best answer is that if you need that true separation, multi-tenancy, of running untrusted codes from disparate people to run them on separate VMs, especially if you're going to be running them as root. Backtrack a bit and say, it's really important to us that you know who built the application, why they built it, sort of all of the metadata around the containers. And so the general security answer is that containers can provide a lot more data about what's running, why it's running, what level of access it requires, et cetera, that you can't quite get in a VM. And that immutable property of those layering schemes allows you to, as an example, when Heartbleed came out, updating all Heartbleed's vulnerable infrastructure with Docker is relatively simple. You update the base at the root, and then everything flows downstream from there. So generally the question is, how does Docker prevent, or back to your patching question, how does it help in the event of a security breach or a security update or something like that? I think in a VM-based world where you have one app running inside of a single VM, addressing all of those security vulnerabilities is actually harder than knowing that you're vulnerable. Whereas with Docker, it sort of solves that problem. Sorry, I answered 2 questions, one you didn't ask and one you did, but hopefully that was helpful.
How do you deal with configuration differences between, say, production and QA?
Configuration differences between prod and QA. Another great question. So one of the easiest answers is, man, you should be building 12-factor apps. So as a result, environment variables. That's one way. The other way is to use more low-level commands that I didn't really talk about, but it's volume management inside of Docker. And so basically you can take your configuration file and put it wherever you would like inside of the container. That's one way to do it. That's sort of like breaking a hole in the immutable side of the thing. You could purpose build, but then you sort of don't get that promotion view of the world. The other option is actually quite interesting, which is imagine you have a container which represents going out into a Zookeeper cluster as an example where you keep your credentials. And its job actually solely is to spin up another container which contains those appropriate configurations. So by separating this out and by creating sort of the base level primitives, you have a lot of options for how you solve that particular problem. And fundamentally, your application shouldn't have to change as a result.
Because in a Windows world, we don't tend to use environment variables.
I understand in the Windows world, things change quite a bit. So we'll have to figure out how we get to that same level of use inside of the container inside of Windows. But I'd say from a Docker API perspective, making variables surface inside is as simple as passing in a -e flag. And so, anyway, we'll get there.
I mean, from a Windows side, having your environment variables, or not environment variables, having your configuration settings off in like an SMB share is typically a cleaner approach than having them built into the OS, right?
Doesn't work so well in the cloud.
Sure. I mean, if you have SMB shares, it does, which Azure has.
Do you want to try this microphone right here? Is that a microphone, actually?
Yeah.
I'm sorry.
Oh, you're loud. Go ahead.
Did you ask about comparing AppV to Docker? I'm going to be honest. I'm a Linux guy. I don't know much about AppV. Maybe.
Yeah, I mean, I think the premise is similar. I think that the idea is fairly close. Like I said, some of the technology pieces are different. Some of the ways in which isolation will be done. AppV has a little bit less focus on isolation and a little bit more just on how to virtualize and move the applications between different environments, right? And simplify startup. And so there'll be a little bit more focus on isolation as we look at sort of how to bring containers onto Windows. But again, some of those concepts, some of even that code may be used to sort of enable containers on Windows. So it's a similar concept. I mean, it's all, to a certain extent, just like Nick said, VMs are a similar concept, right? It's all about virtualization and where your isolation and where your virtualization layer is. And so to a certain extent, AppV is, I think, a little bit higher than where containers will be. Virtual machines is a little bit lower than where containers will be. And so that's kind of the right way to think. In a very simplistic view. The actual details, I think if you can pin Taylor down, he may be able to tell you more. But I do think, actually, I mean, they're working on it now. So some of these questions haven't yet been answered. Yeah, go ahead.
Are you expecting Windows containers to be quite as quick and small as Linux containers?
I mean, we're hoping to make Windows, let me give you the right answer. We're hoping to make Windows containers as small and as fast as possible. Whether they're as fast and as small as Linux, I think we'll have to see as implementation goes through. For those who work with Windows, there's more complexity in making Windows that fast and that small. And so I think there's more moving parts, and there may be less shared that can come out of it based on just the nature of the way Windows is built. So I don't know if that's a fair answer. He's my lawyer. Any other questions? Yeah, go ahead.
Absolutely.
Yeah, great question. So, as we continue to grow out the Docker, our Docker plans and our plans to use Docker, we're looking at a lot of different ways to integrate. I think that a PaaS service, a PaaS solution is definitely something that we want to go dig into. Exactly how and where? Is it websites? Is it a future worker role? Is it a new service altogether? We actually don't know. And we are having those conversations, and they're all on the table. We're really thinking through what's the right way to both integrate and take advantage of the orchestration APIs that Docker's already got and sort of not reinvent the wheel, while still also adding value that only Azure can add value in some of those places. So that's some of the things we're working through. So it's absolutely things we're looking at, yeah.
I'm going to jump in and answer that question slightly differently.
Oh, please do.
And not talk about just from the
I'm gonna
Azure
sit down.
context. No, it's fine. I just want to say there's 3 projects that exist sort of in the open source Docker world today, trying to bring Heroku-like capability into Docker where you can basically git push to production. Flynn is one, Deus is another, and the third, I don't know, there seems to be a Doku is a third. But there's a lot sort of blossoming. The other reality that we're starting to see is a lot of the existing, a lot if not all, of the existing PaaS players are actually standardizing Docker as the container format. And so a lot of options, whether it be through Red Hat and OpenShift or Cloud Foundry with Active State or any of the other, Heroku actually, starting to really invest in the Docker format so that you can get that content from the hub onto their services managed by them. And so the way I would answer sort of what Corey just said is just give it time.
I gave the Azure focus, but yeah, that's good.
I'll be pushing on him a lot to make
that's
sure
right.
that
I'm sure we'll
happens.
have a lot of calls about this. Yeah.
How do you manage processes and know when one is healthy?
So how do you know when a process is healthy? Another thing I didn't show is the event stream. So basically, at any point, at any of your hosts, you can understand if a container started, stopped, killed, why it was started, stopped, killed, by who, etc. And so then you can start acting on that. You can also set policy, like I always want this container to restart. Or you can do crazy things like integrate Docker into systemd and have it managed by an init process or a supervisor process or anything that you've sort of standardized on yourself.
Put the supervisor outside of the container.
You can put it outside or you can put it inside. It depends on your deployment topology. I think fundamentally what you'll hear from us time and time again is we actually don't care how you solve that problem. And that's sort of a benefit to you in that there's a really revolutionary way that you can think of Docker as, thousands of instances running across n number of servers of the hyperscale distributed application. Not everyone's there yet. It's a fundamental goal of the project to ensure that as a result of adopting Docker, you don't have to change anything fundamentally about what you do. It's a net new add. It's not a forklift upgrade. And if we ever break that promise, that's on us. It's not something that you're doing wrong. I'm sorry, you talk
Can
really
your application
low.
be checkpointed and restarted?
Can your application be checkpointed and restarted? Yes, absolutely. It should be very clear. From a process and memory state perspective, that's a negative. There's a project out there where you can do that. So questions about live migration from one place to another, it's in the labs and it works. Whether you can do that consistently across all hosts and all of that, it's actually a pretty hard problem when you don't control the kernel layer as VMs do. But from a container perspective, you can snapshot the container, its state, and move it, and restart the process somewhere else, really simply.
One thing I'll do here before the rest of you leave, learn more. There is a slide here that you can actually get. You can download it. You can take a look right now. Tons of content that you can get and sort of dig into this. There's also content on the Azure blog as well that you can go take a look at and continue to look there on the Azure blog because we will be announcing some of these new things like the Docker client on Windows. Once that's actually released, we'll make that available for you to go play with as well. So and you can go launch that there. So great, and we'll stick around. I think for a few more questions. I think we're nearly out of time. Make sure you do give us feedback. Let us know whether this was a good session, whether it's the right session, whether you enjoyed the content or thought it was going to be something else. We do learn from this. We will get better. Like I said, this was kind of a new experience for both of us with this session. So it's been a lot of fun. And again, if you have more questions, we'll definitely stick around. But in the meantime, I guess have a great Tech Ed. Enjoy your time here, and thank you so much for coming.
Thanks. It's okay. Be sure to check out the Hack Day tomorrow. Yes. We would love it if you guys participated. Right now, there's 50 people or so signed up, so there's a bit room for more. The second is go to docker.com and do the tutorial. Our CFO did it, so don't worry about your technical depth. If he can complete it, anyone can. And I think it really solidifies a lot of what I showed sort of earlier on the command line into a more personal thing. So check that out. And thanks again.